Yeah, no onion today. I didn't look one up. And I really have to screen them now. There's very limited funny ones that are classroom appropriate. Um, well, here, so I guess sort of kind of a funny Olympic story. So I was watching women's luge yesterday, and I guess the Americans have never gotten a medal in women's luge. So this American, I think her last name was Hamlin. She has the run of her life or something like that. Blah blah blah. Literally sets, I think, the fastest time in Olympic history. Okay, so it put her into first place. But there were still two Germans to come up next, who I guess were like heavy favorites to get gold and silver. So before the Germans even went, they're announcing that Hamlin got the bronze. Before they even got to get on their sled. Or their luge. What's it called? Is it called a luge, or is the sport luging, but you're on a sled? Whatever it is. Sure enough, the German that was supposed to get silver beat Hamlin, so new record. And then the German who was supposed to get gold had like such a lead from like the previous thing that she just had to have like a mediocre run. And she may have set the record, actually. I don't know. It was like she coasted to victory. You know, and the interesting thing is like the time difference. Well, the time difference when you're passing the finish line is like, you know, fractions of a second. Mm-hmm. You know, between two different lugers. So she crosses the finish line. She's cheering. I mean, how could you know that maybe you were extra slow that time? And extra slow. I mean, you might have been like a 2 seconds slower. No, she knew. Yeah, so you got bobsled.
Yeah.
So bobsled, you're contained in armor, right? Luge, you're just you and a sled, feet first. But then you have skeleton. Who came up with that name, right? Skeleton is like luge, but face first. No, there's no coming back from a skeleton crash.
Isn't there a two-person luge too?
There might be a two-person luge. There's definitely a 2 and a 4-man bobsled.
Yeah.
Mm-hmm.
I don't know if there's a two-person luge. That's like the equivalent to like one of the roller coaster rides that you have to go on with your parent. So what, they have like a little dude?
Yeah.
Okay. So let's pick up where we left off. Shut up! Oh, I killed Yogi yesterday too. I went into like Yoda mode. Yoda yoga. It was awesome. All right, so at the class last time we had a couple of actors out here. We went in to our actor. We went to his attributes. We added one. I don't remember what the name of the variable was. Anybody remember? What was it called? MyNum. So we called this guy MyNum. And I think we started off as 5, right? Okay, so that means that all instances of actor 1 have an attribute called MyNum. And then what we did is we taught actors of type actor 1 to display some text. So we went down to their behaviors. And we decided to have them display the text that is this particular guy's MyNum. Now, when we run this, they both should show a 5. We can sort of see it, right? Okay. All right, so questions about that in general. Here, we'll change the color of the text. All right. Now, let's talk about Boolean expressions. We haven't talked about those yet, have we? I don't think so. All right, Boolean expressions. It's really funny how they think I don't hear them. I can hear every word they're saying. All right, so Boolean expressions. Boolean expression is any expression that boils down to a single value of true or false. Okay? Remember our Boolean primitive type? This guy back here under primitive types? It's represented as a 0 and 1 as unsigned bytes. These guys hold values of type true and false. Those are the kinds of values that are stored inside of Boolean types. Okay, so then we go back even farther. Let's see. Somewhere in here we have how do humans solve problems, right?
Somewhere.
How do human beings solve problems? Memory, we've talked about variables a bunch. But then we have our secondary thing that humans use to solve problems. That's asking questions. Okay? So let's talk about Boolean expressions. So we have Boolean arithmetic operators. These are operators that most of us should already be familiar with from our math classes. So we have less than, greater than, less than or equal to, greater than or equal to, not equal to, equal to. Make sense? So we're all familiar with these guys. So we use these when we have numbers on either side of the operator. So some examples. Let's see. Let's do it. So I'm going to create a couple of integers. This will be Java code for creating integers. We saw inside of Game Salad how do we create attributes of type integer in there. So I'm going to say int a is equal to 5, int b is equal to 7. Okay, this equal sign is not the equivalence operator. Notice it's a single equal sign as opposed to the double equal sign down here. So this equal sign is the assignment operator. We're assigning the value 5 to the variable a. That's equivalent to what we did inside Game Salad here, where we assigned the value 5 to the attribute mynum. That's of type integer. That make sense? That's where we're connecting the dots between these two. Okay, so I created a couple of integers here. Now we're going to write some Boolean expressions. So I'm going to say a less than b. What does that boil down to? What's a? A is 5. Right? So a is a variable. Variables are named containers for holding values. The value that a holds is 5. So when we say a, it boils down to the value 5. So this is saying 5 less than 7. Is that a true statement? Yep. True. Is that a Boolean expression? Boolean expression is any expression that boils down to a single value of true or false. Okay? So yes, that's a Boolean expression. B less than A. That's false, right? 7 is not less than 5. Is that a Boolean expression?
Yep.
Boils down to a single value of true or false. Okay? A not equal to B. A is 5. B is 7. Is it true that 5 is not the same thing as 7?
Yes.
That's a true statement. That's a Boolean expression. Make sense? Okay. So now we have these things called Boolean logical operators. So again, I'm going to show you the Java code for these, since that's what you'll be using next semester, so rather than coming up with some made-up language. So we have OR. This is the OR operator, 2 vertical bars. And we have AND, the AND operator. I'll show you a couple of other ones that are of interest. We have this guy. And the main reason to show you this is that this is not the power operator in Java. To take something to a power. In Java, this is something called exclusive OR. And I'll talk about that briefly here in a second. Have you guys in the 150 or the 175 class, were you exposed to ANDs, ORs, or exclusive ORs? You didn't talk about that stuff? Okay. Similarly, we have a single vertical bar. This is what's called the bitwise OR. Now, these last three, the XOR and the bitwise OR, these are like rarely used. So I'm telling you about their existence. I'll tell you a little bit about what they do. Beyond that, I'm never going to ask you to use them. Okay, Game Salad doesn't support them. Okay, and then the last one is the bitwise AND. Okay, so to give some definition to these guys, an OR. If we have something, with any of the logical operators, we have a Boolean expression on each side. Okay? So any of the logical operators is going to be Boolean expression followed by logical operator followed by Boolean expression. That's the syntax for using these. Where a Boolean expression is any expression that boils down to a single value of true or false. So this could be another expression that has a logical operator in it. Make sense? So you can have these really complex looking expressions that ultimately boil down to a single value of true or false. So don't think of Boolean expressions being necessarily very simple. Sometimes we're interested in several things that have to occur in order for something to be true. Okay? So, but this is the generalistic syntax for using logical operators, the logical operators. Some Boolean expression followed by an operator followed by a Boolean expression. So an OR means either, well, let's see, how do we want to say this? Left side is true, right, or right side is true, or both are true. One or the other or both. And the whole thing will boil down to true. Or inversely, if none of the Boolean expressions are true, an OR is false. Under every other circumstance, it's true. That make sense? Okay? And this is similar to, real life. If we say, it's sunny and cold today. It's currently still sunny. The snow just started. So I'll give you that. That's the given operation for the word problem. It's sunny and snowy today. Well, is it sunny out? Yeah, that's a true statement. So I'm saying sunny or snowy. It's sunny or snowy today. Is it sunny out? Yep. Is it snowy out? Yep. Both sides are true. True or true is true. Okay. If I said it's dark out and snowy, well, it's not dark out, so that's false. Or snowy, it is snowy out, that's true. False or true is true. Okay? It's dark and 90 degrees, or dark or 90 degrees. False or false is false. Make sense? Okay, so that's an OR. And both sides must be true for it to boil down to true. So as a programming language is evaluating an AND, as soon as it hits something, because you could have a whole bunch of ANDs strung together. You can have this and this and this and this and this. As soon as it runs into something that's false, it stops checking. Okay? That's an important caveat in programming languages. Because you might have 3 or 4 ANDs in a row. And something down the line here might be impossible to do if something earlier was false. Well, by impossible, I mean it might be an error to even try to do this. But with our knowledge of how the AND works, since we know as soon as it hits a false here, we won't check anymore, we can safely put something down here that's reliant on this being true. Because we know if this is false, we won't check this, we won't check this. We won't even try to do it. That makes sense? So programming languages aren't necessarily stupid with that in mind. They recognize that, okay, this is a bunch of ands. They all need to be true. As soon as I hit a false, I'm going to stop looking. Okay? That makes sense? Very, very, very important computer science concept there. It's something you'll use in problem solving often. Okay? And or we don't get that luxury. So it's going to check all of them until it finally hits it. Well, we sort of get that luxury. With an or, as soon as we hit a true, it stops checking. That make sense? So with an or, you might have 10 ors in a row, and as soon as it sees the very first one is true, it's going to ignore the other 9. No sense checking them, because even if they're all false, we're still boiling down to true. That make sense? Okay, that's probably less of a good example of something you'll use often. The and is a better example of something that you'll actually run into, but both of them exist. Exclusive or is kind of like an or. This is left side is true, or right side is true, but not both. So exclusive or says only one side is true. At most, one side is true. Go ahead.
On an XOR, can you only compare 2 arguments in a statement?
No, but it goes from left to right. So let's say you have a Boolean expression followed by an XOR, followed by a Boolean expression, followed by an XOR, followed by a Boolean expression. The first Boolean expression, XOR Boolean expression, will boil down to a true or false first. Then that will become the new left Boolean expression for the second XOR. Does that make sense? So it's each XOR is self-contained within its left and right. But an XOR ultimately boils down to a true or false, which can then be used as the input to another XOR. Okay? Bitwise or. These are a little interesting. Now, we did like internet speed stuff in here, didn't we?
A little bit, yeah.
Okay, we did like binary crap. Okay, good. So the way the bitwise works is instead of looking at these actually work on numbers, but it works on the binary representation of a number. So let's say we had 111 bitwise 100. Good enough. This is going to compare the 1 to the 0 as an OR. So 1 is true, 0 is false. So that's going to be true or false. That's a true. So the output of this for an exclusive OR, I'm just going to go left to right so it's easier to type. So 1 or 1 is 1. 1 or 0 is 1. 1 or 0 is 1. So the output would be 111 in a bitwise OR. So it's really kind of a math function. And like I said, these are rarely used. They're used in completely different types of problems. Bitwise and, same exact thing. You're performing an and, but on the bit level. So 111 and 100 would boil down to 1 and 1 is 1, 1 and 0 is 0, 1 and 0 is 0. That make sense? So, especially these last two. Store these away somewhere as just trivia knowledge. These are things, I mean, it's not that they're unimportant. You might run into these somewhere in your career. Okay? But it's not something that's going to be very common. So, pack it in there somewhere as trivia knowledge that this concept of bitwise comparisons exists. Okay? I'm probably not going to test you on it. I reserve the right to do it, but I probably won't. Hint, hint. Unless I run out of questions to come up with, and then I just throw this one in there to piss you off. Which actually would somewhat be like me. I guess that's a hint, hint. So really, I've told you very little information in the last 45 seconds. I have no plans to make this an important part of the class.
All right.
All right. The exclusive OR, significantly more important that you know what that is. So bitwise is, I mean, we're talking super rare that you'll ever run into those unless you're in a very specific industry or something like that. Exclusive ORs are significantly more common. In fact, in hardware design, so we're not an engineering school here, so none of you are in our computer engineering program. But where I went to undergrad, University of Illinois, Urbana-Champaign, their computer science school is inside the School of Engineering. So we had a bunch of engineering and physics classes and very math-dependent type degree. Just a different focus. This is a more liberal artsy school. That was an engineering school. So one of the classes was an architecture course where we were building hardware, soldering irons and crap like that. So kind of cool stuff. So it's, you're like the guys making the video cards, except those are really, really hard to make. So we weren't making video cards. We were making like stupid little things. Like you took in 4 inputs and something shot out the other side, and a little light lit up, that kind of stuff. But what's interesting though is when you all the graphics card makers, the hardware makers, they pretty much implement all of they're called gates. So they're really writing programming algorithms in hardware. So they're linking Boolean logic together. So when electricity flows through things based on certain decisions, the electricity flows either here or both, and that kind of stuff. They actually implement everything using XORs and something called NANDs, not ANDs. So a not AND would be the inverse of an AND. Okay? So all of them have to be false. That type of thing for a NAND to be true. And we talk about that in our architecture course a little bit here. But the concept is these are universal gates. So with these are called XOR gates, XOR, XOR, whatever. With XOR gates and NAND gates, you can simulate all the other gates. So the reason they use these is because hardware companies, instead of buying all these individual different types, they just buy a zillion of one kind and string them together in the right kind of ways to simulate their what they're trying to do. The reality is, at the end of the day, they're not using these anyways. So these are just for prototypes. Because at the end of the day, all of our circuit boards today are printed circuit boards. So it's basically a thing of silicon with a whole bunch of wires literally drawn on there that flow through drawn-on gates, hardwired gates for speed and performance and all that stuff. But this is not something a human being would be doing. You don't have this dude sitting there with a magnifying glass laying down wire. You have a computer machine, and that's actually one of the newer kind of the technologies. If you ever shop for a laptop and you're looking at the for the processors, some of the newer, well, this is something from like the last 4 years probably, so it's not that new, but the laptop processor, some of them will say this is the Pentium or the Intel i7 whatever 0.76 nanometer. Have you seen those things on there before? That is how close those wires are getting together. So everything's moving towards getting things smaller and smaller and smaller and smaller. Well, there's a point where we can't print wires any closer than that before they start interfering with each other or touching each other at the molecular level. It's really fascinating. So we're actually, our ability to make things smaller and smaller is starting to run into a wall where molecules are starting to piss us off. So now we need to start looking at other avenues of communication, and this is where nanobots and things like that come into play. It's actually really fascinating. This is kind of technology from a human perspective. We saw this with internet speeds. So back in the days of the dial-up modems, when we were sending our, all of our internet was over copper wires, the old POTS Plano telephone service, telephone lines. The best we could do is 56K modems, right? And even then, that was all like based on compression and stuff. So then what did we do? Human beings, we couldn't make it any faster. So what did we do? Well, we came up with a couple of technologies that allowed you to have 2 56K modems, link them together, and one of the companies called it shotgun technology. So if you paid for two internet service provider subscriptions, 2 phone lines from the phone company, and bought 2 modems, you could link those together, and instead of having 56K, you'd have 112K. Wow. Now, what's interesting is that how many of you have DSL at home? At least a couple. How many of you have UVerse at home? That's DSL. Okay. So DSL is running through your phone lines. Old hardwired phone lines. The same thing. The same line that we had the limitation of 56K on. How many of you only have a 56K DSL connection? No, most of your DSL connections are, 6 megabit per second, 8 megabit per second, 12 megabit per second. I think somebody in here said they had like 24 megabit per second. That's getting up there pretty high for UVerse. You basically have to live at the phone company. Because DSL is a technology that's very distance dependent. Okay, so the farther away you get, the less speed you can get. But the interesting thing is using the exact same medium for transmitting data, we went from maxing at 56 kilobits per second to now maxing at 24 megabits per second over the exact same cables. Is that fascinating? Difference is digital versus analog. We were sending an analog signal with dial-up modems. That's what a modem is, modulator, demodulator. So how many of you have ever used a dial-up modem? Yeah, I mean, it's got to be right at the borderline. I mean, most of you probably had DSL or cable pretty early in your life, right? Okay, so the dial-up modem, when they click on, I have a very good impression of a dial-up modem. It's like, yeah, okay. What's that doing? That's something called handshaking. What it's doing is it's talking to the modem on the other side of that line, negotiating what is the fastest we can communicate with each other without screwing up. That's what all that beeping and stuff is, because what they're doing is they're sending information in analog. Your computer speaks digital, so the modem is translating between digital and analog both directions. Okay? So we were sending analog signals over those wires. Best we could do is 56 kilobits. Well, now DSL is a digital. It's a digital technology. So now we're sending zeros and ones over those lines, digitally, and we can get significantly higher speeds. Just kind of fascinating that. But the punchline of that was based off this XOR thing, where most hardware today is built in terms of XORs and NANDs. We don't have companies with a whole bunch of ANDs and ORs just laying around. All right. So questions about any of these? From our perspective, the most important are these first two. ORs and ANDs. Make sense? Okay, so the Boolean operator, the Boolean expression is the core of being able to ask questions. So that gets back to number 2 on how do human beings solve problems. We solve problems by asking questions. So how do we ask questions? We do it through something called an if statement. It gets worse. See, I hate Wednesdays. Wednesday is my least favorite day of the week because I'm here until literally 10:30 at night. I have breaks. I mean, so like I'm going to the golf simulator after this class. So don't feel that bad for me. But, I have a grad class I teach for 4 hours tonight. And it's only once a week. But yeah, you get some weirdos coming down the hall after 6 p.m. They get dinner in them, and then, whatever else goes on.
Wednesday is the last Monday.
Huh? Right here. Yeah, this is the only classroom I teach in. This is my classroom. They've scheduled me in other classrooms before. I still just bring them here. I'm not even kidding. Sometimes they schedule me down there. No, I meet here. This is my classroom. I know how all this equipment works. I've set it all up so it works with my laptop. I'm not going to go screw around with a thing where Dr. Loxler's messing with switches.
Wednesday is early day for me.
Wednesday is the last Monday of the week.
Oh, so you have a Monday, Wednesday schedule, and no Friday's different?
No, it's just that's what we say on my work shift. Right. It's the last day that's closer to Monday than Friday.
Oh, interesting question. we don't have school off on Monday, do we?
No.
Yeah, we have school Monday, don't we?
Correct.
Yes, Monday's President's Day. Today is Abraham Lincoln's birthday. So in Illinois, like my wife is a computer programmer. She works remotely, but she works in Illinois from Grafton. Okay, she remotes in and writes software on a mainframe. But she doesn't work today because Illinois, Abraham Lincoln, that's their president, right?
Even though he's from Kentucky.
Yeah, whatever. But in any case, they have today off, not Monday off. But Concordia doesn't get either of them off. But we have all sorts of religious holidays we get off. So I think we still come out ahead. I was just interested in whether or not we had it off or not. Okay, syntax for an if statement. Again, this is Java syntax for an if statement. It's the word if. And Java is a case-sensitive language, which means that if must be lowercase if. Okay? So it's if, opening parenthesis, Boolean expression, close parenthesis, opening curly brace, do stuff inside here, closing curly brace. Optionally, we can have an else with an opening curly brace, do something else, closing curly brace. Now, in terms of the logic of this, inside the if, this is do stuff when bool expression is true. So that's what we do when the Boolean expression is true. Down here, this is the stuff we do when the Boolean expression is false. So we will only get into one of these, either the block structure. This is a block structure. We'll get into the block structure under the if only when the Boolean expression associated with the if is true. We'll get into the block structure under the else, first of all, if it exists, because it's not required. Else is optional. But we'll only get in there when the Boolean expression is false. That makes sense? So this allows us to ask a question, and if the answer to our question is true, we're going to do this crap. Otherwise, we'll either do nothing, or we'll do this crap if we choose to have an else. That make sense? Okay. Now, the equivalent of if statements inside of GameSal are something called rules. So again, I am inside of my blueprint for my actor. Okay, so if we were making a comparison here, just to kind of keep things connected to Java. Actors, I'm going to say actor blueprints in GameSalad are equivalent to classes in Java. And I'm going to say that is actor blueprints and classes are used to build instances of actors or classes. So copies of them. Okay, so this kind of goes back to like if you've ever seen, some of you might live in one of these communities where every house is the same. You're in some sort of subdivision where all your neighbors have the same house as you, right? But they were all built from the same blueprint, but they're individual houses, right? They have your stuff in there, you've decorated your own bathrooms, that kind of stuff, right? Okay, so that's the difference of taking a blueprint and making an instance versus having the one mansion that only exists one time. All right, so I'm going to go into our blueprint for our actor. And I'm going to go ahead and I'm going to come up here, I'm going to create a rule. So we can actually get rules two different ways. We can either click this button up here to create a rule, which will drop a new rule in here, or under our behaviors, we have a rule behavior, which we can just drag out and put wherever we want. Okay, so it all kind of depends on what makes the most sense for us, because if I click create rule, it drops it next in line linearly. But if I actually want that rule to be up here, I could either create the rule and drag it, or I could just drag it from the behaviors to put it where I want it. Okay? So we're going to add a rule. Now, rules in GameSalad have some things, because it's a game engine, that we wouldn't necessarily have convenient for us in Java. So for instance, this rule is going to allow us to create ands and ors and things like that. But here are some examples. We can respond to an actor receiving an event, which we don't know what those are yet. Or we can respond to a specific attribute, something associated with an attribute. Now, just to give you a brief preview of these events, we're not going to mess with them yet, but the actor receives the event. What are the events we can receive? Well, we can receive a mouse position. So the mouse position is somewhere inside of this actor or outside of the actor. We can receive a touch event. That's for like mobile devices. Overlaps or collides. So when this actor hits another actor. Here's a purchase behavior. So if somebody buys something and pays you money, blah, 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 like this is through the App Store, in-app purchases. Auto rotation, key, mouse button, and hibernate. And we'll mess with all of those. Okay, but right now we're going to be messing with our attributes because we're still practicing with variables. So we're going to ask the question, if some attribute, what attribute? We're going to choose actors, mynum attribute. If this guy is, here's our equal to, not equal to. So notice that it doesn't use the double equal sign like Java, it just uses the single equal sign. Not equal to doesn't use the exclamation point equal sign, it uses the equal sign with a slash through it, which would be very difficult for us to do with the keyboard. Greater than, less than, greater than or equal to, less than or equal to. So all those arithmetic operators are there. So we'll say if this guy is equal to 5, then what are we going to do? We're going to go ahead and display the text how about just working? So we'll display the text working in black. Okay? So we'll go ahead and run this. Everybody relax. That's actually interesting. I think that might be a bug. All right, so now notice I just added a rule into my actor blueprint here. Yet my actors out here didn't seem to get that rule. I think that's a bug. That's not the way it should work.
Isn't it because you have the displaying text afterwards?
Shouldn't be. Because I don't have it in there now. Because if you remember back when we had, here I'll go ahead and display text in here. When we just had this guy, let me take the rule out for right now. Huh. Run this real quick. Go in, modifier actor, display text.
Try changing the color of the text.
Well, that's not the problem. It's literally not in here. I just clicked on the actor. Yeah, something weird with rules. So for right now, this kind of goes back. I mean, and this is fine because this product is a beta. It's been out for a while, but kind of what I said in an earlier class, we kind of have to play by the rules of the matrix. So for right now, it seems like at least in the Mac version of this, when you add a rule, it disconnects from the actors that are out here, which means that what I would have to do is, so I'll go in and put my rules in there. So now I have it looking the way I want it to look, right? It is working on your Mac? Okay, well, I'll try something here in a second, but for right now, I have my blueprint set up the way I want it to be set up. Now I should be able to drag it out here. Except, interestingly, it says hello world instead of working. Let's go ahead and restart Game Salad. Let's call this guy Untitled for right now. That's kind of creepy, isn't it?
It's different.
All right, let's start over here. All right, nothing in there. We'll go ahead and create a rule. We'll say if the attribute is, what attribute? My num. If this guy is equal to 5, if that's true, what will we do? We will display text working. Okay, so there that worked. Now, I think I actually have a theory. I think I can recreate the bug. So this is what I'm going to do. I'm going to get rid of that. We're going to throw display text out here. I'm going to leave it as hello world. All right, we'll go ahead and run it. Here, I'll even change it to black text just so we can see it. And actually, to really recreate it, I'll go in and change it to what we had before. We had our actors, my num displaying, right? Okay, I'll go ahead and run this. Both guys show their my num. This was our initial state today, correct? So we're learning about the matrix. I'm Morpheus. Okay, now hopefully my theory here works. So now I'm going to go ahead and create a rule. I'll drag this guy before here. I'm going to say actor has an attribute that is equal to, come on, we got to choose the attribute. My num is equivalent to 5. If that's true, what I did is I drug this guy up here. I didn't add a new behavior. I drugged the guy from the bottom, and I changed this to say working. You know, my theory here is, I'm hoping it's still broken, is that when I drug a existing behavior down here, it didn't translate well into this rule. Yeah. So something about that behavior. So if I go ahead and delete this and I drag a brand new one out and I say working, change it to black. So something about the behavior already being out here. In fact, let's just see. So now it's out here. It should always say working right now because I have it outside of the statement. And now I drag it back into the rule and then run it. Okay. It's interesting. Drag it outside. Let's change it back to the attribute. Could just be the order in which I added it to the screen. Now it's 5. Drag it back up here. Back to 5. Let's drag it back down here. Let's kill my rule. Let's create a new rule. Drag it up above. Attribute. See, it's just repetition. I'm showing you how this works over and over again. My num, if it's equal to 5. Well, here. We'll run it like this first. Always says 5 right now. I'll go ahead and drag this up there. It's got to be the order in which I drop things in here. Because I can always recreate it. if I drag display text out here first, I should be able to just run this. Then I put my rule in here. Create rule. Actors attribute. Which attribute? Is my num attribute. It's equal to 5. Then what am I going to do? I'm going to say working. And we'll change it to black. Yeah, really the only way to recreate is to literally take the exact steps that we took before, where we have it display the attribute only, then create a rule, then drag that behavior into the rule and change it from displaying an attribute to displaying a word, and it gives you the default state of that behavior. So, again, something to keep in mind that sometimes you have to play by the rules of Game Salad. So I guess if you're going to create a rule, just always create a brand new display text. This could be something that's just related to display text. But in any case, what have we talked about today? We've talked about asking questions. So we now conditionally have something shown in Game Salad. Let me just take our last 2 minutes here to show you this. So if I change, well, let me go ahead and display text. I'll display our attribute real quick. So right now, if it's equal to 5, it should display our attribute, and it's in there. I didn't change the color, but it's there, trust me. Okay, there it is. So if it's equal to 5, it displays it. If I change it to be equal to 6, so this asks the question, if that attribute is equal to 6, then display the attribute. It's not, it's currently 5, so it should display nothing. Okay, I could say if it's greater than or equal to 5, display it, then it'll display it again, which means I should be able to come in here, and I should be able to change my num to 4,000, and it'll still display it, because that's greater than or equal to 5. All right, because my rule says if the my num attribute is at least equal to 5, then display whatever it is. But if I were to change it to be less than 5, and it's currently 4,000, it's going to display nothing. And just to show you the quick else, I can use the otherwise here, which is the equivalent to the if statement's else. And I can throw a display text boo in black. So now this is saying if it's less than 5, display the value. Otherwise, display boo. That make sense? And if I go in and I change that attribute to be 3, now it should display the attribute. All right, questions, comments, concerns, bribes. I will see everybody on Friday.